Welcome everybody back to Three Inquisitive Kids. This is our new video in this playlist, and our topic today is going to be remainders. So remainders are basically the amounts that are left over after you get your quotient in a division equation. I'm pretty sure you guys are all familiar with what remainder means. So in this video, we're going to have two small questions. We're going to answer it, and we're going to use all the knowledge we know about remainders. And if you're a complete beginner to this, I would very recommend you going into our 5th grade word problem skills playlist and checking that out. And I'm sure that we have a 4th grade one as well, so you can get that. Anyway, so let's get into it. 2008 divided by a natural number has a remainder of 10. How many different values can this natural number be? So first, it might seem impossible because we just know one thing. 2008 divided by a natural number has a remainder has a remainder of say a lowercase has a remainder of 10. So this means that we know two things about x. We know that x is let's take 10 away from 2008. 2008 minus 10 would be 1998. So x would have to be a factor of 1998, and also we know that x has to be greater than 10, right? Because why? Well, after it's being divided by 2008, it has a remainder of 10. So the divisor cannot be less or equal to the remainder, meaning that x has to be greater than 10. Well, let's look at all the different factors that 1998 has, shall we? So first, we can start with the different factor pairs. Alright, so let's first find how many total different factors does 1998 have. So we first start with prime factorizing it. So 1998 is equal to 2 times 3 raised to the third power times 37. So this is all of its prime factors. So how many different, factors does it have? Well, we first remember, right now 2 has a exponent of 1 and 37 has an exponent of a 1. It's just omitted because 1 you don't really write as the exponent. Anyway, what we can do is we add 1 to each of these exponents. So this becomes 2, this becomes 4, this becomes 2. We multiply them together and we have 16. So 16 is the total number of different distinct factors it has. And to explain, let me quickly talk about this. If you watched our previous remainder problems in the previous playlists, then you'll know, but I'm going to briefly explain this. So right now we know that 1998 has to contain 1, 2, a maximum of 3/3, and maximum of 1/37. So 2's, you can either have no 2's or 1, 2. 3's, you can either have 0 3's, 1 3, 2 3's, or 3 3's. And 37, you can either have 0 37's or 1 37. So that's why added together, we multiply the different possibilities and combinations it has and multiply them together, which is 16. So that's the total number of distinct factors it has. And how many factors are under 10? Well, you just have to try them and you get 1, 2, 3, 6, 9. So that's 1, 2, 3, 4, 5. 5 factors that are under 10. So we subtract 5 from 16, and we get 11. So our final answer for the first problem is 11. Alright, so let me shrink this solution as I do it. You can read the second problem yourself and pause the video to try to do it on your own. Okay, so let's look at the second problem. A whole number divided by another integer has a quotient of 40 and a remainder of 16. So let's first turn this into a division equation. That's going to be the whole number here, divided by another whole number or integer, x is equal to 40 and has a remainder of 16. And we also know that in here, a plus x plus 40 plus 40 plus 16, because it says the dividend, the divisor, the quotient, and the remainder all added together has a sum of 933. So these are the two equations we get from the question and from the problem. And the question is, what is a and x? What is this dividend and divisor? Well, we can actually do some substitution here, and it has to do with algebra and systems of equations. So if a divided by x has a quotient of 40 and a remainder of 16, it means that a is equal to 40 whole groups of x plus the remaining 16. So now we have another expression to replace a, 40x plus 16. So we could substitute this value into this value, so we only have one variable, which is x. So in place of a, we will write 40x plus 16. And then we plus 40 plus 16, and we know that that equals 993. Alright, so after you solve for x, you can also substitute that into a, and I'll leave that to yourself. And the final answer would be a is equal to 856, while x is equal to 21. So this is the final answer.